Hi, I'm Amar, and I'm an AI solutions engineer at Skyfire, and today I'm going to show you an agent that discovers, accesses, and pays for tools in order to complete a task it's been given. This is a general purpose agent whose backend I wrote with the AWS Strands ADT framework in Python and whose front end is handled with the AWS Agent Development Toolkit library. The agent is entirely prompt based, and what I mean by a general purpose agent is one that can discover new tools, knows how to install them, and knows how to use them. Knowing how to use tools is typically done via descriptions and open API specs or tool descriptions and resources in MCP servers. In this demo, I'll be playing the role of a financial analyst, and I've been tasked with preparing a report on pickup truck sales in the US for 2024. Instead of manually searching for this data, creating accounts, buying data sets, and finally preparing the report itself, I'll use my general purpose agent that is powered by Skyfire's KYA Pay protocol to automate this entire workflow for me. Now, this means my employer no longer needs to make bespoke enterprise deals for premium financial data, and instead my agent can buy the specific data I need when I need it for my reports. Here's an overview of the main steps that the agent will be performing. First, it's going to find a seller of premium financial data. This will be done by searching through the Skyfire directory of services. Secondly, it's going to install the seller's MCP server. Third, it's going to connect to the seller's MCP server. Next, it's going to sign in and authorize with the server in order to use all of the tools available. Next, it's going to find the data set it needs. Then it's going to purchase the data set, and that's going to be done using Skyfire's KYA Pay protocol to create a payment token equivalent to the price of the data set and send that along in the request header when we're fetching the data set. Then we're going to download the data set, analyze it, and then upload the results to Google Sheets, upload the results of the agent's analysis to Google Sheets so that we can review it. So let's take a look at the agent development toolkit so we can see how the agent has run. So this demo is using a simple general purpose agent, as I mentioned, and the agent has been initialized with a few tools to discover, install, and use open API specs as well as remote MCP server tools. And the UI that you're looking at here is provided by the Agent Development Toolkit by Amazon, which enables observability into an agent's cost, timing, steps, and tool calls. So if we look over here to the right, we got the output of our prompt, which was to find a data set for pickup truck sales in the year 2024. If the data set cost is under my budget, then proceed with purchasing the data set and finally retrieve the contents and summarize the data set before making a presentation. So that was our prompt. This was the output of all the agents' efforts. And then on the right, we were able to view the trace, which told us a lot of valuable information. So like the amount of time it took the agent to run, the amount of tokens it emitted, the model it's using, a Bedrock model, and the total number of tool calls required to complete this task. And so now if we press on the Tools tab, we can see all the tool calls that occurred during the agent's run. The MCP client tool, which you can see a lot of being called, like this one right here, is a tool provided by the Strands Tools library, which allows you to connect to MCP servers while your agent is running, which is why you see it called so many times. It's a very powerful capability that the Strands framework provides. And then we can finally see some useful metrics for the agent's runtime. So that's kind of this panel, which lets you observe how your agent has run. So overall, the Agent Development Toolkit is a great UI to inspect how your agent is running. However, because it can be hard to see the entirety of tool inputs and outputs, we're going to review a log file of the agent so that we can see what it's doing in detail. So let's switch over to that now. So here's the agent's log file where it outputs all of its actions as it goes about doing its assigned task. The agent starts off by searching for a seller of the dataset in the Skyfire service directory by using the Find Seller tool. This is a tool from the Skyfire MCP server, which the agent has access to on initialization. We could have been searching any directory of services or even multiple directories, but here we're going to specifically use the Skyfire service directory. After calling the find seller tool, it discovers CarbonArc, who offers its services through an MCP server. The agent then installs and connects to the MCP server, to CarbonArc's MCP server. It then proceeds to list the available tools from this new MCP server and explores the inputs and outputs for each tool. After understanding the capabilities of the CarbonArc MCP server, it starts to plan the sequence of tool calls in order to acquire the data set that we've tasked it with retrieving. So in order to actually call CarbonArc's tools, the agent first needs to create an account with CarbonArc. The agent recognized from the create account and login tool call signature that CarbonArc requires a KYA token from Skyfire plus a password in order to call that tool. So that's why step one is create a KYA token, and then the second is to create an account with CarbonArc. So the agent right here is calling the Skyfire create KYA token tool call to get a KYA token. The Skyfire KYA token encodes the human principal's identity. That is the person behind the agent. Here, the agent is decoding that token, which reveals a verified email address of the principal behind the agent. So we see here the verified Skyfire email corresponds to my email, amara@skyfire.xyz, because I'm the person behind this buyer agent. Sellers like CarbonArc could have required additional info such as name, address, phone number, EIN, but CarbonArc thankfully has none of these additional identity requirements, so a verified email address is sufficient in order to use their service. The agent generates the KYA token with Skyfire and creates or reuses a password and then calls the create account and login tool right here. So we can see the password at the very end. So right there. CarbonArc's create account and login tool in turn presents the KYA token and the password to its CIAM. CIAMs manage user accounts and authorization for applications. The CIAM extracts the human principal's information and creates an account in the CIAM or logs in the agent if the account already exists. The result of this tool call for create account and login is an access token that the agent can use for all further interactions to have authorized access to CarbonArc's tools and endpoints. The agent can subsequently share that password with its human principal so the human can then log into the account in the future if necessary. With the access token, the agent can now call CarbonArc's other tools and now search for data sets. So it's calling the tool name search data sets, and it's found a relevant one, which is the US automobile data set for 2024. Next, it retrieves pricing, which is in this case just 0.002, which is well under our budget of 0.005. Since the data set is within our budget, we can proceed with creating a payment token for the amount of the data set. And right here, we can see that happening where this payment token is returned to us. And we can also decode the token to inspect its contents and see the balance we've loaded up with corresponds to the exact price of the data set we want to purchase. With the pay token created, the agent calls the download dataset tool with the payment token attached as part of the tool call, which we can see right here. It receives a link to the purchase CSV file, which is just the dataset that contains detailed monthly pickup truck sales figures for 2024. The seller, meanwhile, CarbonArc, charges the attached pay token in the request, moving money from the My Buyer agent to the CarbonArc seller account, with Skyfire settling that payment. The agent can then retrieve the CSV file data from the link where it's being hosted using the retrieve file content tool, which you can see it doing here. The agent performs analysis on the downloaded dataset and pushes the results into a Google Sheet using the upload CSV tool to create a presentation for us to review, and a Google Sheet. So that's what this spreadsheet return right here is. For both of these last tools, retrieve file content and upload CSV, they're tools in a reporting MCP server, which is a simple MCP server for routine data extraction and visualization that the agent has also been initialized with, just like the Skyfire MCP server tools. This export and presentation step is outside the Skyfire scope, but it shows the end-to-end data analysis flow that we set out to show. The agent is capable of. Here's what the spreadsheet looks like. So on the left, we can see the CSV data, and on the right, we can see up top, we can see a summary, and on the right, we can see a chart, all created by the agent. Okay, so let's recap everything that's happened in this demo. The agent searched Skyfire service directory using the Skyfire MCP server find sellers tool, found CarbonArc's service, connected to its MCP server, created KYA tokens, which were necessary in order to pass as arguments to the create account and login tool from CarbonArc, searched the data set, searched CarbonArc for the data set we needed, purchased the data set using KYA pay tokens, and downloaded it, and then analyzed the data set and created a Google Sheet for us to review. CarbonArc can then charge the pay token that we've delivered to them and complete the transaction, receiving the money for the data it delivered. With this, the agent has completed the end-to-end flow that it set out to do. If you'd you can fork this repo today and get started building agents that can pay for services on Skyfire. Please feel free to reach out to us with any questions you might have about the code or the platform. Thank you very much for listening.